Alright, so in this video we're going to take a look at really looking at net change versus the end quantity or the beginning quantity. So our key word here is net change. It's the difference between the quantity of a variable at the end state and the start state. So it's the integral, the definite integral of the velocity function or of a rate. If you take the integral of a rate, then you're going to be finding the net change. So if they're saying the rate of water pouring out of a pipe is this, what's the amount of water, what's the net change in the water, that kind of stuff, that's asking basically for you just to integrate. So there is something I want to talk about, and that is that this would be the end value, and this right here is the start value. And you have to interpret what is the question about. So this first assignment, 8.3.1, interpreting definite integrals in context, is really distinguishing the difference of what we're talking here. So if they're asking for the net change, like that water example, what's the amount of water that came out, the total amount of water that came out during that time, they're asking you for the integral. Integrate, find that answer, and there you go. If they're going to ask you for the end value or the start value, it's very similar. What you're going to do, let's just flip this around, f of b minus f of a equals the integral from a to b of f prime of x dx. So if you think about that, all I did was just using the property of equality, I flipped these around. So if you think about it, if we were to take this equation and let's just take this f of a and add it over here to the other side. So if you just picture adding that over to the other side, so we would say that f of b equals f of a plus our integral of the derivative. So here we're saying the ending value, this is the exact same statement as here, the ending value is equivalent to the start value plus the amount of change that happened, the net change. So if you think about it, let's just say that water that's pouring out, we have water pouring out of a pipe into a tub. So here's water pouring out. So the end value, that's really horrible. Water should be, I could use using blue, right? And we have some sort of starting amount inside of this tub here. So water is pouring out of this faucet at this rate f prime. So if I told you that there was 10 gallons of water, a start value, then I would add our net change, which is the definite integral, and that would tell us how much is our ending amount, how much is in the tub at the end of our hour, whatever b is, would be the end. So that's how we would find it. Or if you wanted the start value, let's just take it back a step. And we could subtract f of b to the other side and divide the negative. That's also a possibility to get that the starting value is equivalent to f of b minus the integral. Think about that. That would just be subtracting f of b, so that would be negative plus this. We'd have that negative f of a, and then dividing the negative, so then it would do the opposite of that. So that's a way we can come up with the start value instead. So using this formula, we can rearrange it and come up with different things from that.